Good day, welcome to another video. So here we're continuing with our question 1 series, and yes, specifically we're doing 1.2 and 1.3 as stated in the previous video. So here we're given solve for x and y if 3x minus y equals to 4 and x squared plus 2xy minus y squared equals to -2. So one thing that we notice is that it is a simultaneous equation, right, given two variables, of which the first thing with the simultaneous equation is to identify the equation that is simple to substitute into the other equation. In our case, that is what? That is our equation 2, our equation 1, right? Of which, from that very same equation 1, we therefore pick a variable that will easily substitute and by making the substitute of the formula, right? So I know in class we probably believe that it's a general rule to make y the substitute of the formula, but in reality, whichever variable is easier to work with, we make it the substitute of the formula. So let's first start and check x. Making x, we get 3x being equals to y plus 4, right? Dividing both sides by 3, we therefore get x being equals to y plus 4 over 3. So you can see that this right here is hard to work with. So just like the usual questions we will be getting, y is usually the easy one, but that's not the general rule. So here, using y, we have negative y being equals to negative 3x y plus 4, and then from that we get y being equal to 3x minus 4. When you divide both sides by negative, this becomes our equation 3, right? And then we therefore substitute our equation 3 into equation 2, right? And then upon substituting, we get our x squared and then plus 2x, or y is 3x minus 4, and then minus y squared, we get 3x minus 4 bracket squared, and then all equal to -2, right? And then here we get x squared plus 6x squared minus 8x minus here. I just want to show you something. So these guys right here, this is basically our a, and then this 4 is basically our b, and then this is the sign that we use in what I'm about to show you now. So basically, these, remember from previous grades, right? Actually, let me use a different color for b. Let's use green for b, right? So from previous grades, you know that this, upon multiplying out, we end up with a squared a squared minus 2a minus 2ab, right? And then plus b squared, right? So let's substitute, let's multiply out. Therefore we get 9x squared minus 2a, right? And then b is 4, and then plus b squared this becomes our 4 squared, right? Which is equals to -2. So here we therefore get 7x squared minus 8x minus, let's multiply out, minus 9x squared, negative and negative, we get a positive, therefore positive 2 times 3 times 4, we get 24, therefore 24x, and then this negative times 16, we get negative 16, right? Transpose -2, we get positive 2, all equal to 0. And then from that, we therefore add like terms. Adding like terms, we get -2x squared plus 16x minus 14, all equal to 0. And then from that, guys, let's divide this whole equation by -2. Since it's a common factor, we therefore get x squared minus 8 is minus 8x plus 7 all equal to 0, right? And then let's factorize. Here we get x minus 1, x minus 7. Therefore, x minus 1 is close to 0, or x minus 7 is close to 0. Therefore, we get x being close to 1 or x being close to 7. Let's substitute back into equation 3, which is this one right here. And therefore y, sorry, let me write a proper therefore. Okay, therefore y is equals to 3 in bracket 1 minus 4, which gives us negative 1, or y is equals to 3 in bracket 7 minus 4, which gives us 17. Okay, so we're done with the first question. Now let's move on into 1.3.1. okay, so let me just erase the previous parts so we can continue. I want us to see the question as I continue. So there we are given f of x being equal to x squared plus 8x plus 16, right? So okay, and then they say solve for x if f of x is greater than 0. So basically what they're asking you guys, they're just trying to trick us. Now we have f of x being equals to x squared plus 8x plus 16, of which when they say solve for x if f of x greater than 0, look at this as an inequality. Let it not confuse you. So basically we have f of x being greater than 0, and then this we substitute, we get x squared plus 8x plus 16 being greater than 0, right? So from that we know that we therefore factorize this, we get x and x, and then plus 4 plus 4, right? Of which from this we can say x equals to x plus 4 is equals to 0, or x plus 4 is equals to 0, right? We therefore get x being equals to negative 4 or x being equals to negative 4. So basically this right here is the same root value, right? Okay, anyways, moving forward, this is just a side note. So here we therefore have our critical, I'll just call it a critical value since it's just one, right? But usually we have two critical values that are different. Our critical value is negative 4, right? Or you can alternatively say our critical values are negative 4 and negative 4, whichever way you want to look at it. Okay, so here in a number line we're gonna have our negative 4 here, right? And then we know that when we are given the greater than sign, when we have this sign, greater than sign, we work on our far left and then on our far right. Far left and then far right, right? Okay, far left and far right, right? So here we have x being less than negative 4, or x being greater than negative 4, right? Yeah, so you can verify this in your calculator. Take that very same equation, substitute x values that are less than negative 4, and see if the whole equation does become anything greater than 0. Basically, you must find any number from 1, basically 0.1 all the way up, and then also in a substitute x greater than negative 4, see if you get anything greater than 0 for the whole equation. Just as a demonstration, you can say something like f of minus 5, which will actually give you negative 5 squared plus 8 bracket negative 5 plus 16. See if whatever answer you get is greater than 0. Anyways,